This problem and all other practice problems for Calc 2 here at Rutgers can be found in Sarai Studies. A link is in the description box below. Does the following series converge or diverge? Well, usually I see an exponential, right? A base or a constant raised to some sort of a variable. That's what this is. And then I would say ratio, because ratio is factorials and exponentials. But you could also do root tests. So you could always try it. So the rules for the root test are based on the limit as n approaches infinity of the nth root of the absolute value of your sequence, and that's equal to a limit, or at Rutgers we call that rho. So if rho is less than 1, this series converges absolutely. If rho is greater than 1, the series diverges, and if it's equal to 1, then the test is inconclusive, which means try another test. So the limit as n approaches infinity of the nth root of the absolute value of your sequence, which is n over e to the n over 5, that's what your sequence is here. Note that n is equal to 0, so that means that all the terms in our series are going to be greater than or equal to 0, aka they're going to be positive, so this is already a positive series. And therefore, taking the absolute value of that is just going to be that. It's already positive, makes no difference, because all we have are n's. There's no like trig functions that when we plug in n could give us something that's not positive. So if we have this, then we can use our algebra rules to rewrite it as so, and then we can simplify this further, rewrite this as n to the 1 over n. This can be rewritten as e to the n over 5 to the 1 over n. We can multiply these together, so that would be n over 5 times 1 over n. The n's cancel out, so we're left with 1 over 5. This is a constant, so this is the same thing as just pulling it out and multiplying by 1 over e to the 1 over 5, so we can pull that outside the limit. And then when we plug in infinity, that's just n to the 1 over infinity. Remember that 1 whole divided to infinitely small pieces becomes infinitely smaller, so small it becomes 0. We have n to the 0, anything to the 0 is 1, so we just have 1 over e to the 1/5, and we have 1 divided by something is going to make that smaller than 1. So since rho is less than 1, that means that this series converges absolutely. So for our conclusion, we're going to say since, and then we're going to write the first limit that we wrote down, and we know that's equal to 1 over e to the 1/5. We know that's less than 1. The root test implies that the given series converges absolutely, but they didn't ask us if the series converged absolutely. They asked us if the series converged or diverged, period. So that's where our number 2 tool in our toolbox comes in, the absolute convergence theorem, that says if you have any series that converges absolutely, then that same series is going to converge. And we do have a series right here that converges absolutely, so therefore that same series is going to converge. So we say, and absolute convergence implies convergence by the absolute convergence theorem, so the given series also converges. So the final answer is that this series converges.